So in this video, we're going to look at how to solve the equation x minus 6 equals negative 10. We're going to start with the abstract method. We'll then go to our balance, and then we'll finish it off using counters. Okay, so three different ways of solving the same equation. So I have x minus 6 equals negative 10. The goal is to isolate the variable, right? Leave the variable by itself. We know that both sides of the equation are being separated by the equal sign. And if I want to move any number that is on the same side as the variable, I want to use inverse operations. Meaning if I have addition, I'm going to use subtraction. And if I have subtraction, I'll use addition. If I have multiplication, I will use division, and if I have division, I will use multiplication. So in this case, I have subtraction. So instead of, or in order for me to move this minus 6, I'm going to add 6. But remember that properties of equality say that whatever I do to one side, I need to do to the other side. And this is what we often see in our classes, right? We work with inverse operations. So then we see that we can think about it as negative 6 plus 6 or 6 minus 6. And this is going to give us a 0, leaving me with just x. I notice that I end up with more negatives than positives, so I know my answer is going to be negative. And negative 10 plus 6 is going to give us negative 4. So that's my answer. I can substitute that negative 4 back in the equation and see if it does provide me with a true statement. So a negative 4 minus 6 does equal negative 10. Well, what does that look like if I'm trying to use a balance? We know that an equation can be represented using a balance. And in order for my equation to work out, this needs to be balanced, right? So far, to show what's in this equation, I need an x, and that's going to go on that side. I'm going to need negative 6, so that means I need these, but the negative ones, and I need 6 of them. So there's 1, 2, 3, and then another 3, that's 6. And that's what's on my left side. All right, so there's x minus 6. On the right side, I have negative 10, so I'm going to copy these. And then I'm going to add 4 more. Right. That means I have negative 10. And then I'm going to tell my scale that that's what the equation represents, and therefore it should be balanced, right? That's what we were given. So x minus 6, or 6 negatives, is equal to negative 10. And what I'm trying to find out is, or trying to figure out, is what is x equal to? Just like we did in the previous example, we can, since we have the same thing on both sides, we could remove the same amount from both sides and our equation should still be balanced, right? Our scale should still be balanced. So I'm going to start off by moving these 6 out of the way. And whatever I do to one side, I must do to the other in order for this to stay balanced, right? So there's here the 6. I took the same amount out of both sides, and we can see that x is equal to negative 4. Here we can visually see it in our scale. If I'm using counters, and I'll show you again in a little bit over here, using some of the items that I have here. Okay, so I can think about it as x is representing a box with a certain amount of things in there, a certain amount of counters. According to this, I have a box, and then I have 6 negative counters on the left side, and that's supposed to be equal to a total of negative 10 counters. Well, I know that there's negative 6 of them outside of the box, and I could say, hey, those are the negative 6 that are outside of the box. Well, that means if I'm supposed to have the same amount on the left side as I am supposed to have on the right side, then that must mean that inside the box, I must have 4 counters, right? I could say that I'm going to take away 6 on both sides, just like I did using the balance, and be left with x is equal to 4. I could also use a strategy where, if we want to see how in our equation we said plus 6. Why did we say plus 6? Well, here's what we can do. What I could do is if I add 6 positive counters, right? If I add one there together, those are inverses of each other and they will create a 0, right? -1 plus 1 is 0, but whatever I do to one side, I must do to the other. So there's another 0. If I put a yellow one there, that would be a 0, right? 1 and a -1 is a 0. But again, properties of equality say whatever I do to one side, I must do to the other. If I put this one here, then I must put one here. If I put one there, I must put one there. If I put one here, I must put one here. And if I put one here, I must put one here. So what happened when we added 6 to both sides? This became a 0, that 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 became a 0. That's a 0, 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 and then that's a 0, leaving us with 4 negatives since we had more negatives than the 6 positives that I put in there. Therefore, inside my box, I must have 4 negative counters. You could have also done the same thing over here. Let me take these back. If I want to make the connection with what's going on in my equation, I could grab 6 of these. Let's see, 1, 2, 3. I could grab 6 of these. And what happens when I put them in here, notice that they make a 0. And they make a 0 there, and they make a 0 there, and I need to continue doing that until I am out of negative ones on this side. And so we could have done that here as well to show that if we add 6 positives, that we would end up with 4 negatives. We ended up with more negatives than positives, right?